Ask my instructor, 8.2.13. Find this trig integral. To do this integral, we're going to first start with a Pythagorean identity. So instead of sine squared, I'm going to use 1 minus cosine squared. Distribute the cosine squared into the parentheses and bring the 15 on the outside. And then recognize that cosine squared squared is cosine to the fourth. So I've now written both pieces in terms of cosine squared. And I will use the power reducing formula for my next step. Instead of the cosine squared, I'm going to use 1 plus cosine 2x all over 2. Make the substitution. And the second term is squared. Do you see how it's squared? Go ahead and square that out. Combine like terms and clean it up. Also, bring the 1/4 to the outside. So I've brought my integral down to this, but this still needs some work. I will use the power reducing formula again. And go ahead and do the arithmetic. And pull the 1/2 to the outside. So after using trig identities and a good amount of algebraic work, we have changed the difficulty of the problem from this integral to an equivalent form that is fairly straightforward to integrate. We're using the basic antiderivative of cosine ax. So the antiderivative of cosine 4x is 1/4 sine 4x. And I'm done with the problem. But before I go, I have a comment. At the beginning of the problem, we could have just as easily switched the integral to be in terms of sine x. So instead of going sine squared equals 1 minus cosine squared, I could go cosine squared equals 1 minus sine squared. If we did this, then we would use the second power reducing formula, the one for sine squared. But we would still come up to the same integral. And then remember, from here we used a power reducing formula again. My second comment is that at one point in the video we got to this integral, and perhaps you would have preferred to do it a different way. Perhaps you would have instead preferred to use a Pythagorean identity and then the power reducing formula, but you'll notice that you would still get to the same integral. So the interesting thing about trig especially is there's so many different ways to do it, and so as long as you're coming up with good answers, then don't feel like you have to do it my way. All right, take care and have a great day.